Today I am going to explain you one experiment which is called as OpAmp as a constant current source. That means operational amplifier can be used to keep the current constant. Now let me explain what is exactly meant by OpAmp. This is the symbol of the OpAmp. It is a device which has very high gain. It's amplifier with high gain, and then it has two input terminals. One is V plus and second is V minus, or plus and minus. Plus is called as direct terminal, non-inverting terminal, and minus is called as inverting terminal. You require power supply also, and this is the output. Basically, OpAmp amplifies a small difference between these two terminals to the output, and the gain of OpAmp is very high. So the formula is here: V naught is equal to AOL bracket V plus minus V minus. That means the difference between these two voltages is amplified. Of course, this difference is very small, and OL means open loop gain. Sometimes OpAmp is also used with feedback that I am going to explain you afterwards. Negative feedback and positive feedback both are possible. For example, here if you connect the output to negative terminal, that is called as negative feedback, and if you connect this output to positive terminal, then it is called as positive feedback. So OpAmp has many applications. For example, it can be used to perform mathematical operations like adder, subtractor, multiplier, divider, or voltage to current converter, or current to voltage converter, or power amplifier, or comparator, or instrumentation amplifier. Today we want to see how OpAmp can be used to maintain the current constant. So OpAmp can be used as a constant current source. Now what are the characteristics of OpAmp? Its gain is very high, its input impedance is very high, output impedance is very low, the bandwidth is high, and it is used with split power supply like plus or minus 15 volts, and it is many a times used with feedback, positive and negative feedback. That feedback will decide the gain. Now let us remember two very important golden rules of OpAmp. One rule is that OpAmp will do whatever so that the difference between the voltages at positive and negative terminal will be almost zero. That means it will try to maintain the potential at plus and minus terminal to almost a same value. That is one golden rule of OpAmp. And second golden rule is that its input impedance is so high that practically it allows no current to enter into its terminal. So input current cannot be sent into the OpAmp circuit. So it's the input draws no current, and the voltages between positive and negative terminal, the voltages at positive and negative terminal, they are almost same. These are the golden rules. Now let me explain how OpAmp can be used as an amplifier. The things are very simple. You can observe this circuit now. You can see that positive terminal is connected to ground, and therefore the potential at A is 0. Now one golden rule of OpAmp says that the potential at A and B has to be same, and therefore potential at B is also 0. Now let us see how much current will enter into the OpAmp. See, that current will be decided by, or it will be given by, V input minus VB, the potential at point B, divided by R1. The current entering into OpAmp will be given by V in minus VB upon R1. Now VB is 0 because VA is 0, and therefore the current passing through this branch will be given by V in upon R1. That means the current will depend upon voltage and this resistance R1. Now at B, a part of current is supposed to enter into OpAmp, and a part of current is supposed to pass through this loop. But we have seen another golden rule of OpAmp, which says that the current entering into OpAmp is almost 0, and therefore whatever current comes here, same amount of current will pass through this loop. And we have already seen that the current at this point was V in upon R1, and it depends only upon R1, and it does not depend upon RL, because same current is passing through this circuit as well as this circuit, because input current of OpAmp is 0. So that is how OpAmp can maintain the current constant. Now let me demonstrate the experiment. This is the experimental sheet where you can verify the constant current properties of OpAmp. So let me connect the circuit. See, this is the inbuilt circuit board. This is not a breadboard based experiment. It is a kit based experiment. So I have made the connections. I can make it on here. Now this is power supply, this is OpAmp, and these are the resistors across which the current and voltage can be measured. The first step is like this: connect the power supply to the OpAmp. So make these two connections. That is the first point. Second is like this. The second connection is like this. Use one multimeter as a voltmeter. So what I will do, I will keep multimeter on 20 volts DC. Then I will insert one terminal here, another terminal here, and then I will connect this multimeter across the power supply like this. Okay, remember we are going to connect the terminal here and not here, because this is a fixed voltage terminal and this is a variable voltage terminal, so voltage can be measured. Now so this is being used as a voltmeter. Now let us see how this multimeter can be used as a current meter. So what I will do, I will place black wire in common and then red wire in milliampere terminal, and I will keep this multimeter on 20 milliampere DC current mode. Okay. Now how to connect this multimeter for measuring the current? Here between these two terminals we are going to measure the output current. So this is input voltage and this is output current. So the connections are to be made like this. Positive is here and negative is here. Now whatever current flows through the circuit, you have to give some path to that current. So what you have to do, you have to connect this terminal with this one, so that whatever current comes here will be given a path through this resistor and then it will come to ground. So now there are two controls in this circuit board. One is this control. Using this control you can vary the input voltage. So you can look at multimeters now. I am increasing the input voltage here to different values, and then I am getting the corresponding output current. So the first graph that you have to plot, or the first set of observations that you have to take, they are like this. Set up input current to different input voltage to different values like 0.1, 0.2, 0.3, 0.4, 0.5, and each time measure the output current of the OpAmp. So then once you get this data, you can plot the graph of output current versus input voltage. It will be a straight line. Now let us see how this current can be kept constant by using OpAmp. So now for that the circuit will be like this. Remove this voltmeter now, it is not needed now, and use this multimeter as a ohm meter or multimeter for measuring the resistance. So this terminal will remain, terminals will not change, and then you have to place the dial on 200 ohms resistance. Now how to measure the resistance? See, this is a fixed resistor and this is the variable resistor. I am interested in variable resistor. So how to do the connections? I will insert red wire here and the black wire has to be inserted to ground, but ground is here and the potential at this and this point, they are zero only. So this is also a ground terminal. Now here you can see that there is some value of this resistance, that means 57 ohm. So what I will do, I will set this resistance to minimum value, set 22 ohm, and then I will adjust the input current to some specific value, say 1.86, almost 1.86. Then we want to see how this current remains constant with respect to variable resistance. So what we will do, the resistance is 22 ohm now, and now I will remove this ohm meter which was used for measuring the current, and then instead of connecting this wire here for a fixed resistor, I will connect it to the variable resistor. Now you will find that the current is 1.55. Then remove this wire, give a path through fixed resistor, and then increase the resistance. So for measuring the resistance, you have to connect ohm meter to this resistor, and then you can increase the resistance. Please note that this is voltage control and this is resistance control. So I am increasing this resistance now. I will make it 30 ohm, approximately 30 ohms, and then I will try to measure the current through the variable resistor. So I will remove this terminal and I will connect it here by removing this terminal. So now you can see that the current is 1.55. So for 20 ohm and 30 ohm, the current has remained same, 1.55. I will give one more demonstration. See, I am reconnecting this to fixed resistor so that I can measure the current, and I am connecting this ohm meter once again across this terminal so that I can measure the resistance. Now let me set this resistance to 40 ohm. Okay, so it is almost same. Let us try one more resistance. So I will insert this terminal here, and then I will adjust the resistance to 50 ohms. Okay, by using this terminal. Then I will remove this connection and I will give a part to the current to variable resistance. You can see that the current is almost same, 1.55. So we have seen the dependence of current on output resistance, and we have seen that it remains constant. Similarly, you can do this experiment for remaining currents like 3.82, 5.88, 7.82 and 9.76. So the readings are to be taken in this manner. Keep the voltage to 0.1 volts. The corresponding current is say 1.86 milliampere. Then vary the load from 10 ohm or 20 ohm to 50 ohm, and each time measure the output current. You will see that the current is remaining constant for different currents. Whatever procedure we did for 1.86 milliampere, actually this value can be arbitrarily chosen. You can choose any value, and then for different values you have to see how current remains constant with respect to the output resistance, and then you can plot graphs. One is the graph of output current versus load resistance. So x-axis has load resistance and y-axis has output current, and you are observing that these graphs are exactly horizontal. That means the current is remaining constant. So constant current sources are used in many applications like charging the batteries or for operating LEDs, etc. And OpAmp can be very well used as a constant current source. Thank you.